Other types of equations. So they're going to do a bunch of different equations that we're going to have to solve for an unknown. In this section, they start off with equations containing radicals. So for example, you could have x plus 5 minus 1 equals 2. So without writing a procedure, at your advanced stage of algebra, you should be able to do this problem because you know that your aim or your objective is to get x by itself, right? We're solving for x. So if I'm solving for x, I want to start peeling away things like this -1, this radical, this +5. So as a procedure, right, in order to isolate x, the first thing you want to do is isolate the radical. So in this case, you would have to do +1 plus 1. So you would have radical x plus 5 is equal to 3. Then to get x by itself, you want to remove the radical. You remove a radical by squaring it. So we want to square both sides. So I want to square this side and square this side. So the square root and a square cancel each other out. So I'm going to have x plus 5 is equal to 9. And then I could solve a resulting equation. We could solve this resulting equation. I want to get x by itself. I'm going to subtract 5 from both sides. I get x is equal to 4. X is equal to 4 is what x is equal to. Is it a solution? It's only a solution if you plug it back in and it makes a true statement. So you have to make sure that this is a solution. In this case, it's very important. Check solution or check answer. Right? So we want to substitute this value back into the original problem. We would have a 4 plus 5 minus 1 is equal to 2. Well, that would be the square root of 9 minus 1 is equal to 2. 3 minus 1 is equal to 2. So this one does check. Easy. Easy stuff. So let's look at the second example. We'll use the same procedure. So if I want to follow the same procedure, I want to subtract 3 from both sides of the equation. I'm going to have x plus 7 is equal to -1. I want to remove my radical, so I'm going to square both sides. So I'm going to have x plus 7 is equal to 1. Now I could solve the resulting equation. I want to get x alone, so I'm going to subtract 7 from both sides. I have x is equal to -6. I want to check this, so I want to plug it back in. So I'm going to have the square root of -6 plus 7 plus 3 is equal to 2. I want to see if this is a true statement. Is the left side equal to the right side? -6 plus 7 is the square root of 1 plus 3. And the square root of 1 is 1 plus 3. 1 plus 3 is 4. 4 equals 2? I don't think so. Not a solution. Does not check. Doesn't work. I knew it didn't work right here. Because as soon as you have a square root equal to a negative, it's always going to be no solution, right? I can't have a square root. A square root will never be equal. A square root will never be equal to a negative value. Because a square root written like this, without plus or minus here, right? If there's no sign in front of a value, if there's no sign in front of a square root, it's assumed to be a plus, right? And I can't have a negative underneath the square root because it would be imaginary. So all radical answers have to be equal to a positive value. It's a positive radical. And in this case, right at this point, when we had the square root of x plus 7 is equal to -1, that was a red flag that it's not going to work. So in a perfect world, students say, can I stop there? What should I do? And I would suggest you follow through, and as an answer, you write x equals -6, does not check, or no solution, to show that you did the work and you checked it. And I believe that's what it'll say in the back of the book. So just like the examples prior, I want to get my radical by itself. I'm going to add 3 to both sides. So I will have 2x plus 5 is equal to 10. I want to square both sides. So I'm going to have 2x plus 5 is equal to 100. I want to get x by itself, so I subtract 5 from both sides. It looks like I'm going to have 2x is equal to 95. I want to remove that 2. It's attached by multiplication. So I'm going to divide both sides by 2. I have x equals 95 over 2. Is that a solution? Well, I can check it by plugging it in. So I have 2 times 95 over 2 plus 5 minus 3 equals 7. Make my radical bigger. Well, 2 times 95 over 2, well, those will just cancel out. I have 2 up top and 2 on the bottom. So this is just the square root of 95 plus 5. And 95 plus 5 is 100. And the square root of 100 is 10. And 10 minus 3 is 7. So this checks. Let's take a look at this next example. This one's going to be a little more challenging. Well, our procedure is to isolate the radical. And in this case, the radical is already isolated, right? So we don't have to do that. All we have to do is remove the radical. And how do we remove a radical? We square it. So the first step here, remove radical by squaring both sides. So I'm going to square this side and square that side. I know a square root and a square cancel out, so I'm going to have 20 minus 8x is equal to x squared. I notice that this is an x squared, therefore this is now a quadratic equation. We know 4 ways of solving quadratic equations, right? Factoring, square root method, completing the square, and quadratic formula. Regardless, for most of them, we want it in standard form. So I'm going to transpose these terms to this side. I'm going to have 0 equals x squared plus 8x minus 20. So now my quadratic is in standard form. I have it equal to 0. You could put the 0 on either side. It doesn't matter. If 0 is equal to this is equal to 0. Doesn't make a difference. And now I could either use the quadratic formula, or I could factor this, or I could use a discriminant to see if it's factorable. I would probably just go ahead and try factoring. So I make 2 sets of parentheses. What I put here and what I put here has to give me x squared. So x times x. And then what I put here and what I put here has to give me my 20. So I could do 5 times 4 or 2 times 10, but it has to add up to an 8. So I'm going to use 2 and 10. And it has to be a positive 8, so it has to be a plus 10 and a minus 2. So I could see my inners and my outers give me my b term of 8x, and a negative 2 times a positive 10 gives me negative 20. So this factored correctly, right? So we factored it. Factor and solve. So now I have to solve for x. I'm going to have x minus 2 is equal to 0, and x plus 10 is equal to 0. So here I could add 2 to both sides. So x is equal to 2. I subtract 10 from both sides. X is equal to negative 10. These are values of x. They're not necessarily solutions. So we want to check, make sure they're solutions. So we have to take each one of these and substitute it into the original, make sure it checks. I'll give you a second. So you want to plug it back into the original. I'm doing it here on the side. We would have 20 minus 16, which is 4. And the square root of 4 is 2, and 2 is equal to 2. Right, I plugged 2 in for my x's from the original, and that one checks. That's a solution. How about negative 10? Well, here I have 8 times negative 10, or negative 8 and negative 10. That's going to give me positive 80. So I'm going to have 20 plus 80, which is the square root of 100, which is 10, which is not equal. Oh, I'm sorry. I shouldn't have put 2 here. I should have been putting negative 10 in. And x was negative 10. So those should be equal to negative 10. And regardless, it still doesn't check because the square root of 100 is 10. and 10 does not equal negative 10, even though they're both 10s. This is not a solution. So my only solution to this is x is equal to 2. All right, here's another example. This one's a little bit challenging. I'll give you a second to think about it, right? All right, so this example, just like all the others, we want to get x by itself, but our problem here is I have x on both sides of the equation, and I have a radical. So let's start by removing the radical. Oh, we should isolate that radical before we move it. So we want to isolate radical. So in that case, we're going to have to subtract 2 from both sides of the equation. So I'm going to have the square root of x plus 10 is equal to x minus 2. Right, I can't add those, so I just put them together. I want to remove my radical. Now, in order to remove a radical, we're going to have to square it. So I could square it to remove it, but if I square one side of the equation, I have to do the same to the other side of the equation. So I have to square this entire side. So over here, my square cancels out with my square root, so I'm going to have x plus 10 is equal to, well, x plus 2 squared, it's a binomial squared, so you should be able to do it quickly. It's actually going to be x squared minus 4x plus 4. What? How'd you do that? Well, I did it using the binomial squared formula, right? We square the first term, then we multiply these and double it, and then we square the last term. But if you don't remember that, you could just do x minus 2 times x minus 2, and then you could FOIL that all out, and you would get x squared minus 2x plus 4. But if you're moving on to pre-calc, you want to get used to using that binomial squared formula. Be able to skip algebraic steps because your professor is most likely going to skip algebraic steps. So now we've removed the radical. So now what type of equation do I have? I see there's a square here, so this is a quadratic again. I have a quadratic equation, so I know I have to set the equation equal to 0 and solve. So yeah, we want to subtract x from both sides. We want to subtract 10 from both sides. We want to get 0 over here, so I'm going to have x squared. Negative 4 and a negative 1 is a negative 5x. If you get confused there, negatives are always like debt. I owe my mom $4. I owe my brother $1. So together I owe $5, minus $5. Here I owe $10 on my American Express card. I mail in $4. I'm still minus $6. Right? So x squared minus 5x minus 6, quadratic. It's in standard form. I could factor it. X times x gives me x squared. I have 6 and 1 or 3 and 2. I'm going to go with 6 and 1 because I know a negative 6 and a positive 1 will multiply to a negative 6, and the inners and outers will add to negative 5. So it's correct. So I'm going to have x minus 6 equals 0, and x plus 1 is equal to 0. So I'm going to have x is equal to 6, and x is equal to negative 1. But are they solutions? I don't know. You got to plug them in. So you don't have to write it all out. You should be able to do this in your head, right? Let's cover this one. We're just looking at if x is equal to 6, right? 6 plus 10 is 16, and the square root of 16 is 4, right? So I got 4 plus 2 is 6. So this side is equal to 6, and this side is equal to 6, right? X is equal to 6. So this one checks. This is a solution. Here I'm going to put in -1. -1 plus 10 gives me 9. The square root of 9 is 3. 3 plus 2 is 5. 5 does not equal -1. This one does not work. And it's not because it's negative, it's because it didn't check. A lot of students, as soon as they see negative, they think it doesn't check. It has nothing to do with that. I don't know, it has nothing to do with it. But it's the value after it's substituted into the original equation. That's how we check it. Let's look at this example. This example is different from the examples prior because it has 2 radicals. So this is almost a 2-stage problem. It's like you have to solve this problem twice. The way we're going to approach this is we're going to isolate one of the radicals and remove the radical by squaring. And then we're going to isolate the other radical and remove the radical by squaring. And then we're going to solve the resulting equations and then check. Let's try it out. So I have to remove one of the radicals. I don't know if you have a preference on which radical I remove. It doesn't make a difference. For the sake of argument, I'm going to just remove this one, 3x plus 7 minus radical 3x plus 7. So I'm left with radical x plus 2 is equal to 1 minus radical 3x plus 7. Out of focus. There you go. So I've isolated a radical successfully. So I could easily remove that radical on this side by squaring it. But then if I square one side of the equation, I have to do the same to the other. So I have to square that entire side of the equation. I'm going to leave myself some room to explain, because this is a binomial squared. I could skip a step, but I don't want to do that with you just yet. But right here, these cancel out. So I'm going to have x plus 2 is equal to, and this is a binomial squared. So yeah, I'll do the binomial squared, and then I'll show the work here. It's my first term squared, so that would be 1. 1 squared is 1. I multiply these two, which is just negative radical 3x plus 7 times 1, and double it. So it would be minus 2 3x plus 7. And then I square this term. Well, if I square a radical, right, that's just going to give me plus 3x plus 7. So I did that kind of fast. I'll show it to you in slow motion a little bit. If we have 1 minus 3x plus 7 times 1 minus 3x plus 7, if you were to FOIL this problem, you'd see I would have 1 times 1 is 1, and 1 times negative radical 3x plus 7. And then I have this times this, which again is negative radical 3x plus 7. And then I have a negative times a negative, which is positive. And radical 3x plus 7 times radical 3x plus 7 is radical 3x plus 7 squared. My square root and my square cancel out, and that's where that comes from. Here I combine my like terms. I have a -1 and a -1, which gives me my -2 radical 3x plus 7, and my 1 comes down as well. So you could do it this way, which is fine, but sometimes more work like this, you could make a careless error there. So again, if you get used to a binomial squared, that's always best. So let's clean this up a little bit. And this is kind of a lengthy statement, and I see that I can combine some like terms, just those, right? So I'm going to have x plus 2 is equal to 8 minus 2, 3x plus 7 plus 3x. I want to isolate my radical, so I could start moving stuff over. I could do -8, -8. Should do it in 2 steps. Let's get rid of this 3, -3. I'm going to have -2x minus 6 is equal to -2, 3x plus 7. I've isolated my radical term. I haven't isolated my radical. At this point, I could do one of two things. I could square both sides of the equation, which would work. But right now, I see if I divide by 2, they're all divisible by 2. Divide everything by -2. And then that's gone. Makes the problem a little easier. 3x plus 7. -2 divided by -2 is 1. And -6 divided by -2 is +3. Told you it's a long problem. I finally have my second radical isolated. I want to remove that radical. I know in order to remove a radical, I have to square it. Whatever I do to one side of the equation, I have to do the same to the other. Square root cancels out. 3x plus 7 is equal to x plus 3 squared, which is going to be x squared, my first term squared. I multiply these 3x and I double it, 6x. And I square my last term plus 9. Or FOIL it out. I notice I have a quadratic. So I want to set the equation equal to 0. X squared plus 3x plus 2 is equal to 0. Might get away at one page. I have a quadratic in standard form. I can factor this or use quadratic formula if you hate factoring. 2 times 1 is 2, plus and plus. My inners and my outers give me my 3x. And 2 times 1 is 2, so that's good. I set each factor that contains a variable equal to 0. And then I solve. So I have x is equal to -2 and x is equal to -1. Now I want to take these and substitute it back into the original. And see if it checks. Try it out. Tell me what checks, if anything checks. I'll start with -1 because that's easy to do. I put a -1 in. I'm going to have a negative 1 plus 2 is 1. And 3 times negative 1 is negative 3. Negative 3 plus 7 is 4. And the square root of 4 is 2. So I have 1 plus 2 is equal to 1. Well, that doesn't work. Right? And then if I put in a negative 2, let's see, get rid of my writing here. If I substitute a negative 2 in, well, negative 2 plus 2 will give me 0, so that's gone. And then I put a negative 2 in here. 3 times negative 2 is negative 6. Negative 6 plus 7 is 1. The square root of 1 is 1. 1 is equal to 1. So x is equal to negative 2 and x is equal to negative 1, but only negative 2 checks is the solution. The solution is a value that makes the statement true. That was a long problem and a difficult problem.